All right, today we're going to talk about something straight out of science fiction, but it's happening right now. We're diving into brain-computer interfaces, or BCIs. We're going to look at how they actually work, the lives they are already literally changing, and the wild, complicated future they're building for all of us.
But to really get why this matters so much, I want you to just take a second and think about something. What if your mind was the only thing you could move? I mean, really imagine it. Your entire world of thoughts, feelings, and who you are is trapped inside a body that just won't respond.
You know, for people with certain conditions, like late-stage ALS or a really severe spinal cord injury, this isn't just some thought experiment. It's their life. It's a condition called locked-in syndrome. You are completely conscious, completely you, but you can't speak, you can't move, you can't interact with the world around you. And this is the huge human challenge that really kicked off the whole BCI revolution.
So how in the world do you build a bridge from a totally silent mind to the outside world? Well, the answer lies in creating a piece of technology that can listen directly to the brain itself.
At its core, a brain-computer interface is kind of like a professional translator. It's an electronic system that reads the super complex electrical chatter happening in your brain. Then, it uses some really smart software to figure out what you're trying to do, your intent, and turns that into a command for something outside your body, like a computer or even a robotic arm.
The best way to think about it is like a three-step digital bridge. So step 1, the BCI system records your brain signals while you think about doing something. Step 2, a computer takes those messy signals and decodes them, figuring out what you want to do. And step 3, it sends a command to a device, turning that thought into a real, tangible action, like moving a cursor or speaking a word. Thought becomes action.
Now, there are basically two main flavors of this technology. On one hand, you've got wearable BCIs. Think of these as high-tech caps or headbands. They're non-invasive, which is great, and you see them being used for things like wellness apps or even video games. But on the other hand, you have implantable BCIs. These require surgery, but the payoff is that they can get a much stronger, much clearer signal right from the source. And these are the ones being developed for people with severe disabilities.
And I have to stress, this isn't just theory anymore. This isn't some far-off future. BCI technology is already creating moments that, well, you can only really describe them as miracles. Let's look at a couple of real-world examples that are just incredible.
This is a quote from Nolan Arbaugh. He's paralyzed from the shoulders down, and through an implant, he can now control a computer cursor just by thinking. He's playing chess, he's on the internet, he's using his phone. It is such a powerful example of how this technology can give back a piece of independence that was lost.
And it goes beyond just movement. In another trial, a participant named Brad Smith, who has ALS, used a BCI that was connected to an AI model. Now, this AI was trained on recordings of his own voice from before he lost the ability to speak. And the result? He narrated a video, speaking in his own voice, completely through his thoughts. The technology literally gave him his voice back. It's amazing.
Of course, breakthroughs like these get people's attention, and that means serious money. The global market for BCIs is projected to soar to $12 billion by 2035. That's a huge sign that this technology is making the leap from research labs into the real world.
But with this kind of incredible power, you get a whole new set of really, really difficult questions. I mean, when we can literally read the mind, we have to start talking about the data, about privacy, and all the potential dangers that come with it.
Which brings us to a question that, it sounds like something from a late-night philosophy discussion, but it is now a very real legal and ethical problem. Who owns your thoughts? When your brain activity becomes data, who gets to see it? Who controls it?
The U.S. Government Accountability Office has actually started to map out some of these huge challenges. First, there's data ownership. Who gets that brain data? Then there's the heartbreaking issue they call loss of access, where people in clinical trials get these life-changing implants only to have them removed when the trial ends. And then you get into the thorny ethics of using BCIs to enhance human abilities, and the very scary risk of a machine misreading a brain signal and thinking it's consent when it's not.
The good news is, lawmakers are starting to pay attention. States like California and Colorado have already updated their privacy laws to specifically include neural data as sensitive personal information, which gives it more legal protection. This is literally the very beginning of a whole new chapter in law.
So, just as we're wrapping our heads around brain-to-computer interfaces, researchers are already working on the next and maybe even more radical step. What if we could connect brains directly to each other?
It's called a brain-to-brain interface, or B2BI. And here's how it works in theory. You use a BCI to read information from a sender brain, and then you use a second device, a computer brain interface, to write that information into a receiver brain. You're basically creating a complete circuit for direct mind-to-mind communication.
And if you think this sounds like it's centuries away, think again. The research has been moving shockingly fast. The first studies were back in 2013. The first human-to-human link was shown in 2014. And by 2019, they were already running experiments connecting multiple brains together in a network. The groundwork is already here.
So there are two basic ways this could work. You've got what's called unidirectional systems. That's a one-way street where information just flows from a sender to a receiver. But the holy grail, the ultimate goal, is a bidirectional system where two brains can have a real two-way exchange, a conversation.
But when you look at the actual research that's been done, you see we're not there yet. Almost all the progress has been in that one-way unidirectional communication. Creating a true, direct, two-way conversation between human brains, well, that's the next great mountain that researchers have to climb.
But just imagine if they do it. The possibilities are just staggering. We're talking about therapists being able to mentally guide a stroke patient's brain to help them recover faster, or a team of surgeons or pilots, all perfectly in sync, communicating at the speed of thought. What about completely overcoming language barriers, not by translating words, but by sending the actual meaning, and maybe, someday, even transmitting a pure thought, or a memory, or an emotion?
And that's really what it all leads to, this final massive question. This technology starts out by solving these devastating medical conditions, but it ends up challenging our ideas of what it means to communicate, what privacy is, what identity is. So what does it mean to be human, to be an individual, when our very thoughts can be shared? That's something we're all going to have to think about as this digital bridge to the mind becomes more and more real.